Hello students, my name is David. Today I'm going to show you grade 8, grade 10 mathematics or unit 2, which concerns about exponents and logarithms. Let me say this section has two sections, that is exponents and logarithm with their graphs. Today I'm going to show you that the exponents part. So before we are going to define what exponents of numbers means. From grade 9 lessons you have learned about radicals and taking square root of numbers or taking any root of numbers. So to set exponents, let's say if n is any positive integer, then we call what? If the power of n is expressed as a times a, it continues just like this. How many times? This is n times. This means the exponent, when we talk about exponents, means when we say we know that there is a repeated addition, we can say that there is a repetition of multiplication with the same number. In this case, we can write as exponents if n is any positive integer and a is any real number. Okay, where a is any real number, we can say that a the power of n can be written as a times a continues just like how many times? N times. So these numbers are the factors with the same identical factors, but we are going to multiply it how many times? N times. That is how we can say that exponents. For example, let's say, for the power of 4. See, for the power of 4 can be written as, you have to multiply 4 how many times? 4 times. This means 4 times 4 times 4 times 4. You see, this means becomes what? Multiplication of the number 4, the base 4. How many times? 4 times, which is equivalent with 256. 256. Or you can prove it that 4 times 4 is 16. 16 times 16 is 256. So this is how can we write exponents. By the way, when you say exponents, that exponents may be integer or rational or irrational. In general, you can say that real numbers. But let's start from the smaller one, that is positive integer. Okay, positive integer. Again, don't forget exponents can be also a negative integer. Okay, it can be also a negative integer. In this case, we are going to see n is a positive integer. This means we are going to multiply these numbers as what? N times. You see, this is how can we write exponent or exponents the numbers. Let's say another example. Let's say negative 5 to the power of 3. This means we are going to multiply negative 5 how many times? 3 times. This means negative 5 times negative 5. You see, this you can see that this means the negative times negative 5 times negative 5, which is equivalent to negative 5 times negative 5 is 25. And 25 multiplied by negative 5 is negative 125. Do you see? When you multiply the base with an odd exponent, the value of the sign of the base can be determined. Whatever it is, negative or positive, if the exponent is odd, we have to get as the number it is. If it is positive, our final answer is positive. If it is negative, it is our final answer is what? A negative. But in the case of even exponent, whatever is the base, whether it's negative or positive, the answer is always what? Positive. You can check it, or you can refer from grade 9 textbook. The next one is let us see the rules of exponents. Okay, rules of exponents. You see, as we say that exponents means multiplying the base how many times as much as possible as the exponent. There is a rule for exponents. To simplify the numbers. Okay, the first one is let us say that a the power of m times a the power of n is the same as the same base but different exponent. This means we can multiply a times a the power of m times a the power of m. We can say that a to the power of m plus n. This means multiplying power numbers with the same base means taking the or adding the exponents of the same bases. For example, let's say example 4 to the power of 5 times 4 to the power of 8. For example, let's say this is the exponents are completely different numbers, so we can say that a to the power of m times a to the power of n means a to the power of m plus n. So the same base but different exponents. We can say that 4 to the power of 5 plus 8. We are going to add the exponents. Okay, the exponents. So finally it becomes what? 4 to the power of 5 plus 8 is 13. This is equivalent with the first one. That's 4 times 4 to the power of 5 times 4 to the power of 8 is the same as with 4 times 13. Let me show you, for example, let's say by using what? The same thing. We say 2 square times 2 to the power of 3. This means we can say that to the power of 2 plus 3, which is to the power of 5. Let me multiply this one. To the power of 2 means first 2 times 2 and times to the power of 3 means 2 times 2 times 2. Now count the number of 2's, how we are going to multiply. 1, 2, 3, 4, 5. This is the first, the second exponent, and this one is the first one. So when you count, it becomes what? To the power of 5, which is similar with the previous one. Okay, similar with the previous one. The second rule, or the second important rule about exponents is you can say that a to the power of m over a to the power of n, where a is different from 0, don't forget that. A to the power of m is different from 0. It can be written as a to the power of m minus n. See? A to the power of m over a to the power of n means a to the power of, with the same base. By the way, don't forget again here, the bases are the same. If the bases are completely different, we have to follow another rule. So this means the base a and raised to power m minus n. M minus n. Let us see the example. That is 5 to the power of 10 divided by 5 to the power of 3, for example. If so this means which is equivalent to 5 to the power of, you see, the same base, 10 minus 3, which is 5 to the power of 7. Or you can say that, or let me prove these numbers. You have to multiply 5 how many times? 10 times, and you have to multiply 5 again in the lower base, or in the denominator part, how many times? 3 times. Then the number 3 at the numerator part can be simplified by the 5 numbers, or the 3 5s with denominators. For example, let's say that just like this: 5 times 5 times 5 times 5. You see, times 5. 5, how many 5? 1, 2, 3, 4, 5, 6, 7, times 5, times 5, times 5, you see? And all divided by what? 5 times 5 times 5, you see? Now 5 is cancelled by this one, 5 cancelled by this one, this also cancelled by this one, and count the number of the remaining 5's, you see? 1, 2, 3, 4, 5, 6, 7, which is 5 to the power of what? 7, which is similar with this one. The third step, or the third rule, is talking about what? It is talking about a to the power of m, the whole to the power of n. This means, you see, the base are a, and the one of the inner exponent is m, and the outer one is n. This can be written as a to the power of m times n. In this case, we are going to multiply, but when we multiply bases, don't multiply the exponents. So you have to add exponents. So this is how can we simplify the exponents with brackets. For example, let's say, to the power of 3, the whole to the power of 5. This means, you see, we are going to multiply to the power of 3 how many times? 5 times. This means to the power of 3 times 5 is 3 times 5, which is equivalent to the power of 15, which is similar with to the power of 15. So this means we are going to multiply to the power of 3 how many times? 5 times. So you have to take care on such kind of solving questions. And these are very important for simplification of exponents with bases. Okay. The fourth property talks about a to the power of b, the whole to the power of n. You see, a to the power of b, the whole to the power of n can be written as a to the power of n by multiplied by b to the power of n. This means with different bases with the same exponent means we can multiply the base as each of power 4. So for example, let's say, for example, 5 times, let's say 8, the whole to the power of 2, let's say 2. That means we can say that by this rule, we can say that 5 squared times 8 squared. You can check it by yourself. 5 times 8 is 40. 40 square means, let's say, 40 square, which is equivalent to 25 multiplied by 64. You can 40 square means 1,600, which is equivalent to, which is the same as 1,600. The same thing. Okay, you can check it by yourself. So in this case, you can simplify just like this. A times b the whole square means a to the power of n times b to the power of n. You can multiply as power form of individually. The last or the fifth one, actually this is not the last, there are many rules, we have to follow them. But in this case, the fifth one is a over b, the whole to the power of n can be simplified as, don't forget again, b should be different from 0. This can be simplified as a to the power of n divided by b to the power of n. You can, the power of the fraction can be, or the fractional exponent can be written as the exponent of each terms or each parties. This means we can say that a to the power of n divided by b to the power of n. We can show that, or we can take as example of with numbers. Okay, with numbers. For example, let's say 5 over let's say 4, the whole to the power of 3 can be written as, or it can be equivalent with 5 cubed divided by 4 cubed. You see, 5 over q means we have to multiply 5 over 4 how many times? 3 times. That means 5 over 4, see, 5 over 4 times 5 over 4 times 5 over 4 can be written as, you see, 5 times 5 times 5 divided by 4 times 4 times 4, you see. And you have to remember that when we multiply fractions, we have to multiply numerator by numerator and denominator by denominator. So 5 times 5 is 25 times 5, 125. See, 125 divided by 4 times 4, 16. 16 times 4 is 64. See, 64, which is equivalent with 125 divided by 64. So in this case, in both cases, they are the same. But what is the importance of doing such kind of properties or such kind of rules is to simplify the numbers. For example, say if the number cannot be simplified as a fraction and exponent, we can simplify as what? Each exponent or each power form of as a fraction. Okay, we will see the examples related with such kind of rules. So this kind of we can use those rules. For example, let me simplify, or let me see examples. Okay, examples with simplification of by using what such kind of rules. Example 1. Let's say 1. Simplify a. A says what? 4t the whole square times 4t the power of 7. Power of 7. B, we can say that y the power of 3 the whole to the power of m. C, let's say C, 16 times 4 the power of, or for the power of 5x. 5x, you can say that this one. D is better example for 10 to the power of 5 divided by 10 to the power of 7. Okay, let me solve this kind of relations, or let me add another example, which is E. Let's say 4x over 5y the whole to the power of 3, for example, say, and f which is very related with this one. Let me say that like 3 times 4t the whole power of 20, let's say 20, you can say that just like this. So to solve this, we have to use these rules. The first rule is the second, the third, the fourth, and the fifth one. So we have to follow these rules to simplify this kind of problems. So to solve this, let me see one by one. In easiest and applicable use of or applicable method of solving linear or exponents of bases or exponents of functions. So let's start from A, solution here, solution A. A says what? 4t the power of what? 2 times 4t the power of 7. You see, the first rule says that the same base with different exponents means when we multiply two powers, we can add the exponents if the bases are the same. In this case, we can say that 4t is 4t. In this case, we have to take the base 4t and we have to add the exponent that is 2 plus 7 because the bases are similar. Therefore, we can say that 4t the power of 2 plus 7 is 9. Yes? To the 4t the power of 9 can be simplified, or which is equivalent with this one. And b y the power of 3 the whole the power of m. In this case, we are going to multiply the exponents because in this case multiply y the power of 3 how many times? M times. In this case, we have to multiply the exponents. That is y is equal to y the power of 3 times m, which is y the power of 3m. If m is defined number, you can multiply by 3 and finally come to that power 4. C 16 times 4 the power of 5x. Now we are multiplying different numbers. In this case, we have to, if it is possible to one of the numbers to change the other bases, it is possible to change this one. You see? And the number 16 can be written as 4 squared. Yes, 4 squared. That means 4 squared times, see, 4 the power of 5x. Don't forget that 16 can be written as 4 squared. And finally, we have changed to what? Just example in A with the same base but different exponents and multiplying the two powers or the two power forms. In this case, 4 the power of 2 plus 5x. This means it is 2 and 5x cannot be added because they are unlike terms, so we have to put as the number it is 4 the power of 2 plus 5x as it is. So you see, these are the final answers after we simplify. D says what? D 10 to the power of 5. See? 10 to the power of 5 divided by 10 to the power of 7. This means dividing the power with the same base. This means 10 to the power of 5 minus 7. Because if when you divide powers with the same base and different exponent, take the denominator's exponent to the upper one and subtract it. That means 10 to the power of 5 minus 7, which is equivalent to 10 to the power of negative what? 2. This means 5 minus 7 is negative 2. We will see negative exponents of different expressions. Okay, so this means 10 to the power of negative 2. E says what? 4x over y, 4x over 5y, the whole the power of 3. This means the same as with 4x power of 3 divided by 5y the power of 3. Again, these exponents work for both 4 and x. This means 4q times x cubed divided by 5q times y cubed. You see, the cubes are for not only for 4 and 5 or not x and y, it works for both terms. This means 4 cubed is 64 and x cubed as the number it is x cubed divided by 5 cubed is 125 and y cubed is as the number it is. So finally we can put just like this. 64 the power of 64 times x the power of 3 divided by 125 y power of 3. This is the number 3. So we can simplify just like this. F says what? 3 times 4t the power of what? 20. This means these numbers are works for what? Again, for 3 and 40. This means you can say that 3 to the power of 20 times 4 to the power of 20. You can find out by using calculators, because this number, this exponent is very large number. N multiplies 3 how many times? 20 times. And so it's too much large number to calculate on whiteboard. You can't find out by a calculator. So the same thing, but we are going to see what expressions or the method, how can we simplify the numbers. Or you finally can say that 3 times 40 is the same as with this one. Or 3 times 40 means 120. You can say that, or you can consider 120 the power of what? 20. You can say that just like this. The last, actually we have finished. This how can we simplify by using what? Exponents. Next, we are going to see exponents of 0, 80. And this means when whatever this a to the power of 0 is how much time, or how is the value of a to the power of 0, a to the power of 0. You know that 0 to the power of 0 is meaningless number, yes? The power of 0. This means we know that 0 to the power of 0. First, let us see 0 to the power of 0 is meaningless. See? This is meaningless, which means does not exist in the set of in operation system of mathematics. That means 0 to the power of 0. This means nothing, the power of nothing is senseless. Okay, it is senseless, or it cannot be solved in mathematics or mathematical rules. But when you say the second rule, a to the power of 0, where a is different from 0, it could be one different from 0. What it may be what's negative, positive, decimal, or any other numbers, but it cannot be 0, and which is equivalent to a to the power of 0 is equal to always 1. Always 1. To prove this one, we can use practical examples just like this. For example, let's say 10 to the power of 10. Let's make it simple. 10 to the power of 3 divided by 10 to the power of 3. You know that this means 10 to the power of 3 is 10 times 10, which is 1000, right? 1000 divided by 1000, yes? 1000 times 1000, which is equivalent to what? 1, yes? Right. This is obvious, this is true. We are going to start to prove this kind of numbers by practical example. So, by the rule of division of powers with the same base, we can take out the exponent of the numerator and to the numerator of the exponents. That is 10 to the power of 3 over 10 to the power of 3 can be written as 10 to the power of 3 minus 3. This is, you can see that just like this, because the bases are the same. The bases are the same. That means 10 to the power of 3 minus 3, which is 3 minus 3 is 0, yes? 0, that is 10 to the power of 0, which is, you know that 10 to the power of 0, but 10 to the power of 0 is already been proved, that is 1, which is equivalent to 1. That's why the reason that a to the power of 0 is written as what? A to the power of 0 is 1. So you can take another example by using what different numbers. For example, say what is the square of 23, the power of 0. See? Whatever is the base, whether it is rational or irrational or real or integer, but in this case the base will be different from 0, it's always what? 1. Whatever it is, okay? It may be decimal number, it may be fraction, it may be irrational, it may be real, or it may be any other form of the numbers, but the power of exponent 0 is what? 1, except the base is 0. Except the base is 0. Let us see, after we have seen power of zeros, let us see the power of negative numbers, okay? Power of negatives. See? Negatives. This means previously we have seen, you see, 10 to the power of 5 over 10 to the power of 4 is equivalent to 10 to the power of 5 minus 7, which is 10 to the power of negative. What does it mean? We have to answer such kind of questions, yes? So, where a is any real number other than 0, okay, when a is any real number other than 0, a to the power of negative n, and n is a positive integer, okay, where a is any real number without 0, and n is any positive integer, okay, any positive integer that can be written as a to the power of negative n can be written as 1 over a to the power of n, okay, a to the power of n, or you can say that this means 1 over a the whole to the power of n is positive because this number is 1. But if this number is not 1, it does not work with this one. Okay, it can be written as just like this. So this is how can I write. For example, let's say let's say 5 to the power of negative 3. This means you can see that 1 over 5 power of 3, which is equivalent to 1 over 5 cube is 125, right? 125. This is equivalent the same as with the x. Whatever is any value, you have to write as reciprocal. Okay, that's the reciprocal. You know that, for example, let's say 1 over 2 can be written as, see, 1 over 2 can be written as, or which is equivalent to negative to the power of negative 1. Or we can say that 1 over 4 can be written as 4 to the power of negative 1. And from your physics and chemistry lessons, you have written such kind of numbers by using a scientific notation. For example, say if the number is, for example, 1, you know that 1 kilometer is 1,000 meter, right? To convert 1 meter to 1 kilometer, you have to write, this means, you see, 1 over or to the power of negative 3 kilometer, right? To the power of negative 3 kilometers. This means 1 over 1,000. The same in this case, we have to use the rule of negative powers or the rule of negative exponents. I think it is very simple, or it's very easy for power of negative numbers. We see the power of rational numbers. Okay, the power of rational numbers. By the way, it works for what the fractional part again. Okay, it works for the fractional part. This means, for example, let's say a over b, the whole the power of negative n is equivalent to the reciprocal of what this one is. Right? This means b over a, the whole the power of n. We can write just like this. For example, let's see such kind of numbers. 2 over 3 the whole the power of negative 2. See? Negative 2, let me erase it. This one. 2 over 3 the power of negative 2 means the same as which you can invert the, or you can reciprocate the inner fraction that is equivalent to 3 over 2 the whole square, which is 9 over 4. The same as you can check it by yourself. In this case, it can be the reciprocal. To show this one, just make it this number of 1 over, okay? 1 over, okay? When you say, for example, you say 2 over 3, the reciprocal of 1 over 2 over 3 is, you know that reciprocal, that is 1 over 2 over 3. This means dividing the number 1 by 1, 2 over 3. This means equivalent to 1 divided by 2 over 3. And you can convert this to 1 times 3 over 2. You see? 1 times 3 is 2, which finally becomes what? 3 over 2. Let's see, the reciprocal of this one is becomes what? Such kind of statements. And don't forget that in doing mathematics, you have to practice different types of exercises from different books. Unless if you hold the examples done by teachers, you will be what looks like a dormant. Okay, you have to exercise. Okay, exercise. If you don't exercise, your knowledge may be losing or evaporates, and you have to keep exercising by different examples. And let me see examples. For example, the simplification of such kind of relationships. Example 2, which is simplify 8 says what? The number, let's say 5 the power of 5 the whole the power of 2n, actually we use such kind of functions. B 16 the power of 2x plus 3 over 16 the power of 2x minus 3. C 49 the power of x over 7 the power of let's say y. You can say that just like this. And D, finally D becomes 164 the power of a multiplied by 4 the power of D 64 the power of a. This is numbers a times 4 the power of a. Let me see one by one. A 5 the power of 5 the whole the power of 2n. You see, this means we are going to multiply 5 with 2n. That is 5 the power of 5 multiplied by what? 2n, which is 5 the power of 10n. We can say that we can simplify just like this. B 16 the power of 2x plus 3 over 16 the power of 2x minus 3. In this case, the same base, but exponents are different, and the power division, we can say that 16 the power of 2x plus 3 minus 2x minus 3. This means you can see that 16 the power of 2x minus 2x, 2x and 2x are like terms, plus 3 minus times minus is plus, so it becomes what? 3 plus 3. So finally it becomes what? 2x minus 2x is 0. 16, 2x minus 2x, 0, 0 plus 3 plus 3 is 6, which is equivalent to 16 to the power of 6. You can simplify just like this. C, 49 the power of x divided by 7 the power of y. Now here the number 49 and 7 are completely different numbers. So and again we can mix or we can change the number 49 as base of 7. So this means 7 squared the whole power of x divided by 7y. Now we have changed the exponents to the bases to like radicals or like bases. 7 squared the whole x means 7 the power of 2x over 7 the power of y, which is equivalent to 7 the power of 2x minus y. Now 2x and y are different terms, so we can't subtract. So we have to put as the number 7 the power of x minus y. D 64 the power of a times 4 the power of a. In this case 64 and 4 are completely different bases. Again we can change 64 as a base of 4. This is 64 means 4q, right? 4q the whole the power of a times 4 the power of a. 4 the power of a. In this case 3 times a is 3a. This is equivalent to 4 the power of 3a times 4 the power of a. And the same base with exponents, so we can add exponents. 4 the power of 3a plus a is 4a, right? So this is the simplified form of 4 the power of, or 64 the power of a times 4 the power of a. Let me see the other types of powers, which is rational exponents. Rational exponents, and you know that rational can be written as a form of fraction, or when we change it as decimal, that decimal may be either terminating decimal or repeating decimal. If it is none of this, it cannot be rational. Instead, we call it irrational fraction. So rational exponents. Okay, rational exponents. Let's say when we say it's a rational exponent, if a is greater than or equal to 0, see, if n is an integer, s and n is an integer, see, a the power of 1 over n means you know that the n is root of a. You know this one. You have to know this one. This is the rational exponent, or you can say that the exponent's relative is what? Rational. So we can say that n the power of 1 over n. You see, the number this is a rational exponent. You see, this is a fraction number. Okay, it's a fraction. So we can write as n is root of a, which is equivalent to what? n the power of what? 1 over n. Don't forget again, if n is even, this number, the number inside the bracket must be what? Positive. See, if n is even, a must be what? Positive. Yes, positive. If it is n is even and a is negative, you see over here, if n is even, for example, say for negative 16. This number is not in real number. This cannot be defined in the set of real numbers because the number 4 is even, but the number inside or the radical part is a negative. See, in this case, there is no any number where when we multiply as even times, it becomes what? Negative or negative numbers. For example, say negative 2 the whole power of 4 is always even. This means negative 2 times negative 2 times negative 2, you see, times negative 2, you see, negative times negative is positive times negative times negative, it becomes what? Positive, that becomes what? 16, right? 16. So this is must be what? Positive always. So in this case, it cannot be existed in the set of real numbers. That's why we can say that a should be greater than or equal to 0. It works for even as well as all integers. In this case, don't forget, if n is even, the number inside the radical must be even numbers. Okay, it must be even number. So we can express such kind of numbers. For example, let's say example express as radicals. A says what? Or we can say that as 3 to the power of 1 over 4. This is B says what? 64 to the power of 1 over 5. We can say that C, let's say 1 over, or we can say that 32 to the power of 2 over 3. Let's write this one as radical form. See, the solution part becomes what? 3 to the power of 1 over 4 means A. 3 to the power of 1 over 4 means, consider the 4th root of 3, right? The 4th root of 3. B, when you come to B, 64 to the power of 1 over 5. Again, the same thing we would like write this one. 60, the 5th root of 64. You can't say that just like this. And see, the last one, it's what? Fraction is different, or the exponents, the numerator is different from 1. That is 32 the power of 2. We can say that the whole the power of 1 over 3. So in this case, 32 square, we can written as the third root of 32 square. We can say that we can write just like this. This is how can we express, or how can we write rational exponents into radical roots. Again, we can say that different kinds of statements that can be written as when you say this general rule, if A is greater than 0 and M and N are positive or integers, you can see that with N is greater than 0, with N is greater than 0, or sorry, N is greater than 1. That means if we write A to the power of M over N can be written as A to the power of M the whole to the power of 1 over N, or you can say that this can be the n root of A to the power of M. We can write just like this. So this example works for what? Example C. This is the rule how can we express rational exponents. For example, let's solve examples. Okay, example. Simplify. Let's say simplify A. Simplify. This is what the cube root of negative 27. B. This is A. B. The 7th root of negative 128. C. Let's say the 5th root of negative 32 over the 5th root of, or let's say negative the 3rd root of negative 64. We can simplify, or let's simplify this examples relating with rational exponents. A. The cube root of negative 27. Yes, this can be written as negative 27 can be negative 3 cube. Yes, and the whole the power of 1 over 3. This means you can write the cube root as what? The power of 1 over 3. So this can be written as negative 3 the power of 3 times 1 over 3. Which is 3 times 1 over 3 means this is multiplication. It's by 3 1 by 3 1. Finally it becomes negative 3 the power of 1, which is equivalent to negative 3. It can be simplified just like this, or you can take out easily the cube root of negative 27 is as 3. B says what? The 7th root of negative 128. You have to simplify, or you have to know the power form of 128. That is negative 2 the power of 7. See, the power of 7 is 1 negative 128 over the power of 1 over 7. This number 1 over 7 comes from the 7th root. See, the 7th root is the same as with this one. Negative 2 to the power of 7 times 1 over 7, which is equivalent to negative 2. The same thing, this one. C says what? The 5th root of negative 32 divided by the 3rd root of negative 64. This means you can write as a number this one first. negative 32, or we can write 32, negative 32 as to the power of 5. See? Negative 2 the power of 5, the whole the power of 50 means 1 over 5, right? Again, over negative 64 means you can write as a power form of 2, or you can, as since it is negative 2, or we can write as negative base negative 2 the power of what? 6, right? 6. Again, the whole the power of what? 1 over 7. This means, you know that we can multiply this number, yes? Negative 2 the power of 5 times 1 over 5 divided by negative 2 the power of 6 times 1 over 3, right? So this can be simplified as, this becomes what? 1, negative 2 divided by, see? Negative 2 divided by, can be written as 6 times 1 over 3 is negative 2, right? That is negative 2 the power of 2. This is negative 2 the power of 2 means we have to simplify first. Negative 2 over 4, which is equivalent to negative 1 over 2. So finally, it becomes what? Negative 1 over 2. Negative 1 over 2. Okay. Let me see, before we are going to see irrational exponents, what is an irrational number means. Okay, what irrational number? To see, previously in grade 9 we have learned about rational and irrational. Okay, putting together there's two types of, you see, Q and I are together. You see, we can say that the union of Q and I is equivalent to this real number for any rational number and I. Let's just say irrational, when you say it's irrational number, like radical 2, see, radical 7, or the fourth root of 8, just kind of numbers are said what? Irrational numbers. You see, when we take out this number 2 from the radical, it is impossible to find out, or the exact number, or the digit should be what? Non-stoppable as well as what? Non-repeatable. In this case, when you convert it to a decimal number, and if you get when the number is either terminating or repeating, it is called what? Rational. But when you divide or when you change it to a decimal, if the number is non-terminating as well as non-repeating, it is called what? Irrational number, like radical 2, radical 7, fourth root of 8. You see, this kind of numbers are with what? Irrational numbers. So when we come to the irrational exponents, let's say that the number is a the power of x. You see, a the power of x where x is greater than 0 and x is irrational number. You see, irrational number. We can say that there is a number. Let's say a the power of x1, which is less than a the power of x4 less than a the power of x2, where x1 is less than x, which is less than x2. You see, this means the number x is irrational number and x1 and x2 are rational numbers. You see, rational numbers meaning, for example, let's say the number radical 5 is found between what? Found between two rational numbers. You see, radical two rational numbers. That is 2 and 3. You see, when you square this number 4 and 3, so the number 2 is less than radical 5, which is less than 3. The square of 3. After you square it, you will get 4 is less than 5, which is less than 9. This is in this case which we said what irrational exponents. So whatever is the value of x, so if you say that in the power of radical 5, see, we can say that this means this is the same as the power of 2, which is less than the power of radical 5, which is less than the power of 3. See, the number the power of radical 5 is found between a square and the power of 3, because the number radical 5 is found between 2 and 3. That is how can we express irrational numbers, irrational exponents. So let us say simplify, or let me simplify the numbers. Example, simplify, see, simplify for the power of radical 3 times for the power of radical 27. See, 27, you can this A, this is for A, and for B, you can say that find the power of radical 25. Actually, this number is a perfect square number. Let me make it irrational, radical 98 divided by 5 to the power of 2 times radical 7. See, let me write this one, or let me make it simplify simple, radical 2 radical 2. So to solve this one, let me see a. So a says what? 4 the power of radical 3 times 4 the power of radical 27. In this case, the bases are the same. See, the same. So by either of multiplication of exponents or multiplication of power formulas, you can say that 4 the power of radical 3 plus radical 27. So these numbers can be added after we change it to what? Like radicals. Like radicals. Don't forget that like radicals can be added or subtracted. But if it are unlike, this is possible to add or subtract. But we can change the number 27 as like radical. This means 4 the power of radical 3 plus, this means radical 9 times radical 3. It's possible, see? So the number 9 can be taken out from the radical, that is 4 the power of radical 3 plus 3 times radical 3. So this can be written as 4 the power of radical. The coefficient of the first radical 3 is 1, and the coefficient of the second radical is 3. So we can add 3, 1 and 3. That is 4 radical 3. This is the simplification form of this statement. For the power of radical 3 times for the power of radical 27. Let's move to b. When you come to b, 5 the power of radical 98 divided by 5 the power of 2 radical 2. This means the numbers, the bases are the same, so we can write by using the power division of the exponents. 5 the power of radical 98 minus 2 radical 2. But the number, these two terms are unlike radicals. But it is possible to change the number radical 98 to radical 2. That is 5 the power of radical 49 times radical 2 minus 2 times radical 2. This is the exponent for b, not the base. This is equivalent to this number, the radical of 49 is 7. 5 the power of 7 radical 2 minus 2 radical 2. So now we have changed the exponents to like radical. So 7 minus 2 is 5. So finally it becomes 5 the power of 5 radical 2. This is how can we simplify power of irrational numbers. This is enough for today. Next we will see logarithmic functions. Thank you very much. Don't forget to